All right, welcome everyone again to another one of Mr. Martin's math videos, Pre-Calculus 12 for Canadian B, British Columbia curriculum. We're on Chapter 6, Section 3, Proving Identities of the trig unit. 6.3, Proving Identities, we're really getting into the meat of this chapter here, which is all about proofs, what we've been talking about from the beginning, but we've just been setting up to this point. All right. So proofs can feel difficult sometimes. Unlike other topics in math, there's not always clear. It's not always clear whether you're in the right direction. Sometimes the two most important things you need to in proving identities is perseverance and creativity. So you gotta, go at the same problem in different, with different strategies. If you're not able to solve it one way, try a different way and come back at it. Okay. In this section, we're going to be using the identities we have already proved in previous section to prove more complicated identities. All right. So again, have your formula sheet out so that you can reference, especially those we talked about last set of notes, the sum identities, difference identities, and double angle identities. And also make sure you understand the Pythagorean reciprocal and quotient identities as well from 6.1. So let's take a look. Example 1 is stop complicating things. So when doing proof, it is very useful if you can simplify a complicated expression rather than complicate a simplified expression. So this is just, we're just going to be looking at different approaches, different tools that you can utilize as we're solving these kinds of problems. Okay. So in this situation, what we want to do, again, you have, let me change my pens. All right. You have this, okay? So now we're actually proving an equation, all right? And it's important when we're proving an equation that we can be working on both sides at the same time, okay? Also, we want to be, changing our double angle identities and making everything into cos and sine, okay? Now, on the top here, we already have cos and sine, but it's sine 2x, and so that's not a very easy thing to always simplify, so we're going to convert that one into 2 sine x cos x over cos x plus, then we'll choose something in the middle here, and this is going to be 1 over sine x. Okay, I'm going to change that cosecant to sine x. And then I have to choose between my three double angle identities here. Okay. So because I need to end up with sine so I'm going to, on the left side here, and my cos, this is going to cancel out, so I'm going to be left with sine. So I'm going to go with the sine identity of cos 2x, which is the 1 minus 2 sine squared x over sine x. Okay. Now over here on the left side, this becomes over 1, right? And I want my equation, because I'm adding fractions here, to simplify, I want to have a common denominator so I can add rational expressions. So here, I'm going to multiply the top and bottom by sine x. And that's going to give me 2 sine squared x over sine x plus 1 minus 2 sine squared x over sine x equals 1 over sine x. Okay. From there we can continue to simplify here. Notice that when we're adding this, the 1 sine squared x over here, and 2 sine squared x on the left, and the negative 2 sine squared x on the right, they end up crossing each other out, which leaves me with just the 1 over sine x, which is equal to 1 over sine x on this side. And that means I've proven my identity. Okay, so that's your task. Okay, this is an example of what it looks like when you prove an equation. Okay, using these trig identities, you can be working on both the left-hand side and the right-hand side. You're not just working on one side or the other. Sometimes it's helpful to simplify both sides at the same time to end up, as long as you end up with something that's equal to each other. That's the point, okay? And then you've proved it, as long as your steps are clear as well. I'm going to say this right now. Your steps need to be kind of really spelt out, okay? You don't want to be skipping algebraic steps here, because the point is not getting to a final destination, but the point of these kinds of problems is proving all of your steps along the way, like you're trying to explain it to someone. So if you're skipping steps, people aren't going to be able to follow. And so I have to be able, the person who's grading your assignments and tests, I have to be able to follow through with your steps to understand them if I can give you full marks that you actually, because anyone can just like write gibberish and then just have 1 over sine x equals 1 over sine x at the end. But I have to be able to see each algebraic and make sense of each algebraic step along the way. So make sure you're working in a tangible and organized fashion. All right. Another important tip here is to pay attention to the cos squared x. All right. There are 3 different identities for this expression, whereas it's not cos squared x, it's cos 2x. Whereas sine 2x only has 1, right? There's 3 identities for cos 2x, but sine 2x only has 1. So usually it's more useful to substitute for any sine 2x terms you see first. All right, that's what we did at the top here, right? Here we did this first, right? Here, this was our first step, okay? And then based on some minor simplification that we did there, that helped us make our decision for the cos. Now they're both green. For the cos 2x later on, okay? And that's the kind of order you want to see. Working together, example number 2. All right, in this example, we're going to deal with each side independently until they look the same. One strategy we'll employ is to use the conjugates and when to use them. All right, if you remember these, multiply by the conjugate. Hopefully that rings a bell. One thing we have to do is not cross the equal sign. Okay, you can't like multiply something on both sides to cancel things out. Whatever you're simplifying on the left-hand side, that algebra needs to stay on the left-hand side, and same thing on the right-hand side. Okay, doing so already assumes that the identity is true, which is not allowed to do until you know that it's true, right? The assumption that whatever you do on one side, you can do on the other side, and so you're crossing things over from one side of the equal side to the other, is assuming that you've already proved it, that the equation is true, but we don't know it's true until we've proved it in the first place. So that's why we can't use those kinds of strategies. Those are off limits. Okay. So now let's take a look here, proving this identity here. This would be a good example. So I don't have anything to turn into sine and cos. Everything's in sine and cos. Everything is, there's no double angles, there's no sum identity or difference identity. And so here, what I'm going to do here is I'm going to multiply this by a conjugate. All right, so I'm going to take 1 minus cos x and multiply it on the top and bottom. I'm not multiplying it to both sides of the equation, but I'm multiplying as if I was multiplying that side of the equation just by 1, which doesn't change the value of that side of the equation. All right, and so on this side, this is going to give me sine x minus sine x cos x. All right, and below this is going to give me 1 minus cos squared x. Okay, and on the left side I haven't done anything yet to that. Okay, now this 1 minus cos squared x, hopefully you recognize something to be done with that, right? If I do sine x minus sine x cos x over 1 minus cos squared x is equal to sine squared x according to the Pythagorean identity. Okay, check it out if you don't believe me. And so now the sine squared x I can divide by both. I can divide the sine of the sine squared x, right, from on the top and bottom, right? So the sine here and the sine here would cancel out the 2, which would leave me with 1 minus cos x over sine x, okay? And lo and behold, that's exactly what we have here, okay? So I've proven my identity, okay? Now, as you're proving one side of the equation, you don't have to rewrite the left side of the equation every time. Typically, I'll work on one side of the equation and kind of get as far as I can until I feel like it's simplified and I'm approaching the other side. But then I'll also work on the left side of the equation and then go from there, at different times. Okay, but you don't have to be rewriting everything each step of the way. Okay, as long as it's clear that each side of the equal sign at the end of the day is the same, you've done the task. You've done your duty. All right. Here's an example for you guys. I want you guys to try this one out. It's your turn, so go ahead and pause the video, take out a piece of paper, pencil, your formula sheets, and give it a crack. Take a crack at it, I guess is the better expression, and then unpause the video when you're ready to go over it together. All right, hopefully that went well for you. Okay, so let's take a look. First thing I'm going to do, the left-hand side is pretty simplified. I'm not going to touch it yet, but I'm going to look at the right-hand side here. There's some secants, there's some reciprocal functions, trig functions that I can, or identities that I can turn into coses and sines. So that's what I'm going to do. So here I have 1 over cos x minus sine x times 1 over cos x over cos x. Okay. Here you can factor out the cos x, or if you do 1 over cos x divided by cos x, that what that actually gives you doesn't really cancel out here. It actually compounds. Maybe I'll factor it out. So I'm going to factor out 1 over cos x, and that's going to give me 1 minus sine x over cos x. All right, and that's going to give me 1 minus sine x over cos squared x. Okay, because you're multiplying by the reciprocal, you're going to get cos x times cos x on the denominator side. Okay, so we've done some good work here. On the left-hand side, here, what I'm going to do is maybe use a conjugate, because I need to end up with cos squared x here in the denominator based on what I've done on the right-hand side. And so I can, this 1 plus sine x, if I can change this, if I can get this to a 1 minus sine squared x, and I know because of the Pythagorean identity, I could switch that to a cos squared x. So in this situation, I'm going to rewrite my equation, but only so that you guys can see that I'm multiplying the top and bottom by the conjugate. Okay, so 1 minus sine x, 1 minus sine x. Okay, and that's going to give me 1. And notice here, I worked on the right hand side completely independent. I made it a ways, and then I just start working completely independent on the left hand side. So that's how you can organize your work as well. So 1, and that's going to give me 1 minus sine x over 1 minus sine squared x, and of course I know that 1 minus sine squared x is equal to cos squared x, thanks to the Pythagorean identity. And lo and behold, we've arrived at the same thing on both sides of the equal sign. And so we've proven this identity. Well done. Hopefully that went well for you. Okay. One last problem here. is where we can, and here, like you're seeing the conjugates being used, factoring out, certain numbers. There's other types of trig and algebraic rules that we can incorporate, even some old Math 10, Pre-Calc 11, factoring, good old factoring, right? And we were factoring trig equations just in 6.1. And so we can pull out some of that as well as we go along using, what we call the A method, if you guys remember that. So another pro tip here, when both sides look relatively complicated, it's sometimes helpful to change a little bit on the left side, then a bit on the right side, then back again, and then back again until both sides look the same. Okay, and we kind of saw that approach in the last question. You'll see that approach again in this section. So first thing, again, we want to change things, coses and sines. We want everything to be coses and sines, and so cotangent becomes, so again, my equal sign is going to be here. So cotangent becomes cos x over sine x, and then minus 1 over sine x. Okay, which is nice. I got a nice common denominator there, right? So it's going to be cos x minus 1 over sine x. Okay, so that's kind of simplified a little bit. Let's see here. Okay, so I'm going to do the denominator first. All right, because here in the denominator, I have the double angle sine 2x, and there's only one substitution for that one, so I'm going to go ahead with that. So 2 sine, I'm going to make it in red just so that you guys can see it. 2 sine x cos x, and then that's plus sine x. And on the top, in this situation, I'm seeing on the left-hand side, I have, sines on the bottom and coses on the top. Here, I can kind of see there's some sines more on the bottom than cos, and so if I can focus on having cos on the top, maybe that'd be a good approach. So that's what I'm going to try here. So I'm going to choose to replace it with 2 cos squared x minus 1, and then minus cos x. Let me make this in red. 2 cos squared x minus 1. All right. Now, you'll notice here what you end up with. Okay, let me rearrange this so it's a little bit... actually, let's do that in the next step here. So I'm going to rearrange the top part, the numerator right here, by degree. Okay, so I end up with 2 cos squared x minus cos x minus 1. And on the bottom, it looks like I can factor out that sine x. So I'm going to go ahead and do that. Okay, so I'm going to get sine x, and then I'm left with 2 cos x plus 1. All right. All right, now here, the reason why I wanted to order this in degree, because we know how to solve and simplify these. We know how to factor these, right? We can use the A method to get to work on this one. So I can replace all of the cos by just the A variable. So I get 2a squared minus a minus 1. All right, and then this is just factoring, right? You know that your product needs to be -2. Your sum needs to be -1. And so you're going to split that middle A value into -2a and positive a minus 1. And then we're going to group that all together. I'm going to factor out the 2a, and I'm left with a minus 1. And factor out just 1, which leaves me with a minus 1. Okay, which leaves me with 2a plus 1 and a minus 1, right? So I factored that. But now I can substitute. I know that my a is actually equal to cos x. Okay, so I'm going to put cos x back in. Okay, so I'm going to put cos x back in. I'm going to get 2 cos x plus 1 and cos x minus 1. All right? So now I'm going to plug that in. I'm hoping that you're seeing the potential for this, right? Because here, if I put this over here, 2a, let me zoom in a little bit here, 2a, oh sorry, not a anymore, 2 cos x plus 1, and then cos x minus 1 over what I had already down here, 2 cos x plus 1. Hopefully you're seeing that you can cross some of this out, right? 2 cos x plus 1, 2 cos x plus 1. And lo and behold, what do I end up with? Cos x minus 1 over sine x, which is exactly what I had on this side here. Okay? Now, kind of made this look easy, partially because I've done these problems before. If I was going through these problems for the first time, I probably would have gone through some trial and error kind of sequences as I tried to prove these. Okay, so as you're going through these, just give yourself time and be determined and patient to get the right answer. It's there somewhere. Okay, you just got to work at it. So for now, we're going to be on 6.3 for a couple. I guess because of this online format, it's going to be like a week. Because I'm going to give you guys lots of extra practice in this. Okay, it's not going to be enough just to do the questions in the homework. And you're going to have questions in the homework. And so post those questions on the homework channel in our teams, in our team. And but then we're going to do some extra assignments for this, okay, so that you really get a hang. A lot of this is just practice. You're going to start recognizing pieces of equations that will be hints to you, that aren't hints to you now because you have an untrained eye, but as you do more of these, your eye will be more and more trained. So just trust the process. All that goes. That's all I'm saying. So just for now, this is the homework for now. I'll be assigning this later on, but you don't have it yet. And so just for now, that's 6.3 homework, 7 to 19, and not all the numbers, obviously, but this will be to be uploaded in the assignment that I set up in Teams for that assignment. So be watching out for that. And again, if you have questions, help each other out. Use the resources available for you guys. And also next class, we'll be able to hopefully look at some examples as well. All right. Hope this video was helpful for you, and have a good day.